Welcome back everyone to Learn Invitation. Today we're in dynamics and we're going to solve problem 15.73. Okay, it says two smooth disks A and B each have a mass of 0.5 kilograms. If both disks are moving with the velocity shown when they collide, determine their final velocities just after the collision. The coefficient of restitution is E equal to 0.75. Alright, so what we're given here basically is this to this disk A and this B. They're telling at each one to its respective velocities, and they're going to collide. And over here, they give us a description on the way that you're going to collide. Okay, so we're just gonna try to find out the velocity at the end, and we'll see how we're going to do this. So the first thing I like to do in this problems is just basically just write out my givens. So let's just go ahead and write out my given that the mass of my disk A and my mass of my disk B, both of them are equal to 0.5 kilograms. So we're writing that one out. We're given that the coefficient of restitution is equal to 0.75. And the velocity as well, each velocity is described over here. Okay, so we're gonna solve this utilizing our chapter 15 equations. These two equations, like mainly the conservation of momentum and the coefficient of restitution equation. Okay, so for this problem, what we have to do is that, well, we have velocity in the x and also velocity in the y direction for mass B, for my disk B, right? So what we're going to say, like, all right, let's separate this into two different directions. So we're going to start with the conservation of momentum only in the x direction. So we're focusing on the x direction. We're going to assume that going to the right is positive. And what do we have? Well, this is our equation over here. So we need to do the summatory of the masses times the velocity. So we have the mass of my disk B, 0.5, multiplied by its velocity. Well, the velocity in the x direction is going to be 3 over 5 times its magnitude, okay? So we got 3 over 5 times its magnitude, which is 4, okay? So this is our momentum for disk B in the x direction. Then for my disk A, we got 0.5 multiplied by 6. Well, this is entire velocity is just going to the left. So I'm assuming, I'm sorry, I forgot to put the negatives. So we got -6 because it's going to the left. And all this should be equal to, well, the mass of my disk B times the velocity of B in my second state in the x direction. Okay, so this is a 2 in the x direction plus the mass of disk A times its velocity after the collision in the x direction. Okay, so now we have one equation, and I'm going to simplify a little bit, modify it so it looks better. The first thing that I'm going to do, well, I realized that every single term has 0.5, so I'm going to cancel it out in both sides of our equation. I'm going to move my variables to be on my left side, therefore we're going to have that the velocity of B after the collision in the x direction plus the velocity of A after the collision in the x direction has to be equal to the addition of those two numbers. And when we plug this into our calculator, let's see how much we get. We get a total of -3.6. Okay, so this is our first equation, and as you guys should probably know, we will need a second equation, and we're going to utilize our coefficient of restitution. So let's go ahead. We're going to utilize the coefficient of restitution for our second equation. So as given before, well, I was given in our problem statement, we got the restitution is equal to 0.75, and this should be equal to the velocity of B after the collision in the x direction minus the velocity of A after the collision in the x direction, all divided by, well, the velocity of A before the collision, therefore -6, remember it's going to the left, minus the velocity of b before the collision. Well, again, it's going to be 3/5 times 4 for the velocity only in the x direction, okay? So from this one, what I'm going to do is that this will become 0.75 equal to the velocity of b after the collision in the x direction plus the velocity of a after the collision in the x direction divided by, and I'm going to add these two negative numbers, and that gets me a total of -8.4. Lastly, just to a final simplification, we're going to have the velocity of b after the collision plus the velocity of a after the collision has to be equal to the multiplication of 0.75 and the -8.4, and this should give me a total of -6.3. Okay, so now we will have our second equation. So we got two equations for two unknowns. What I'm going to do is utilize these equations in the format that I put them in here in order to get a matrix. By the way, I believe I did a mistake. This is a minus in here, therefore this should be a minus, and also in here. Okay, now that we fixed our second equation, we can go ahead, utilize our matrices, and we will find out that our velocity of v in the x direction is going to be equal to -4.95 meters per second, and the velocity of a in the x direction after the collision is equal to 1.35 meters per second. Alright, so now we found the velocity in the x direction for this. Now the only thing that we're missing is the velocity in the y direction. So we're going to utilize the same kind of like step as our conservation of momentum. So what I'm going to do is, let's go ahead and start conservation of momentum. But in this case, it's going to be in the y direction. I'm going to grab our picture and I'm going to put it over here so we have a better view of our problem. So put it up here. And we're going to assume that going up is positive. And what do we have? Well, at the beginning, what we can see is that the velocity of b is the only one that has anything in the x direction. So we start with 0.5. Its mass times its velocity, which is going to be 4/5 multiplied by its magnitude, which is 4, and this should be equal to 0.5 multiplied by the velocity of b in the y direction after the collision. And you guys may ask, but what about the velocity of a in the y direction after the collision? Well, what happens is that since both balls, if we were to zoom in into here, both discs are hitting like this. Therefore, just by momentum, my disc A will want to go towards my right and my B towards my left. However, since we have initially only in B some Y, we will end up having a final resultant force like this, okay? So that's why the velocity of B is the only one that is included in this equation. So what we can do is cancel out 0.5 in both sides, solve for my velocity of b in the y direction after the collision, and if we do that and we plug this into our calculator, see how much we get a total of 3.2 meters per second. Okay, so finally, in order to finalize our problem, what we have to do is find the magnitudes of the velocity of b and its direction. So let's go ahead. So the magnitude of the velocity of b is going to be equal to, we're going to apply Pythagorean theorem, the velocity in the y direction, in the x direction, 4.95 squared, plus the velocity in the y direction, 3.2 squared. We plug this into our calculator and we find out that this is equal to 5.89 meters per second. Its direction, we're going to call it theta of b, is going to be equal to the inverse tangent of the y direction, which is 3.2, but the velocity in the y direction, divided by the velocity in the x direction, negative 4.95. And when we do this, we will have a negative value of negative 32.9 if we round to 1 decimal place degrees. Now what we can do is replace this negative value for, instead of being counterclockwise, being a clockwise angle. So what do I mean by that? Our angle is going to be like this, going clockwise. Also, another thing to state is that this angle is with respect to my x-axis, like this, as we would expect, but it's with respect to the negative x-axis. Okay, so this is our velocity of B, and for our velocity of A, well, since velocity of A only has in the x direction, we got 1.35 and is totally straight to our right direction. And this should be our final answer. So this velocity of B with its direction and the velocity of A. So I hope you guys liked the video. Please push the like button, subscribe, and I'll see you guys in the next one.